Good morning, good afternoon, everyone. Today we are diving into Databricks Lakeflow Spark Declarative Pipelines, specifically how to build production-grade data pipelines using a declarative approach that eliminates most of the complexity you are used in. Now, the core insight of Lakeflow is simple but powerful. You declare what you want, not how to compute it. And Databricks handles the orchestration, checkpoints, retries, and state management. Let us start with the big picture. Every Lakeflow pipeline follows this Medallion Architecture pattern. Now, bronze is your raw ingestion layer. Yeah, think of it like the source of truth, immutable, unfiltered fact. Notice the key feature here. Now, incremental file ingestion, only new files, never reading everything. Schema inference, Databricks figures out your schema automatically. Rescue column for drift, captures schema change without breaking. Exactly once processing, no duplicates, no data loss. Now, this rescue column is critical. In production, schema will change. Your pipeline shouldn't fail at 3 a.m. because, for example, marketing add UTM_campaign field to the JSON. The rescue column captures it. You investigate it in the morning and decide whether to evolve the schema. Now, the silver is where clean and validate data resides. Yeah, this is your analytic ready layer. Now, you have here, for example, you do typecasting. String becomes dates, numbers, or booleans. Yeah, booleans. Yeah, deduplication. You do duplication. Keep only the latest record per student, for example. Data quality rules here is use drop because invalid rows are filtered but logged. Yeah. Now, anatomy or anomaly filtering is quarantine bad data. Let good data continue. The reason we drop at silver instead of fail is operational resilience. A handful of malformed records should not stop your entire pipeline. We filter them out, alert on thresholds, investigate as asynchronously, and good data keep flowing. Now, gold is the decision ready, as you can see. The gold is the decision ready business intelligence here. You have coarse level metrics, aggregation that business users consume. You have risk calculation, business logic encoded in SQL, Python. You have data quality gates. Here you fail. Strong contracts, fail fast if broken. Decision ready output, feeds a dashboard, reports, machine learning models. Now, notice at gold we fail instead of dropping. Why? Because gold feeds critical business decisions. If our contract breaks, negative student counts, percentage over 100%, for example, we want to stop and fix it, not silently produce wrong answers that leadership acts on. Now, let us see the first one, the concept, just in much details. Concept number one is like the streaming first. Even though we are ingesting CSV files, which is static files, we treat this as a stream. Why? Because batches ingestion does not scale operationally. With batch, you reread everything, you need custom deduplication logic. Rerun are dangerous as well. With streaming, though, Databricks checkpoints what has been processed, new files process incrementally, failure pick up exactly where you left off. Now, think of it like streaming video with downloading the whole movie every time you want to watch the next episode. Streaming is incremental by design. Now, the autoloader is a Databricks intelligent file watcher. It is not a file format, it is a source connector. Now, automatically discovers new files in cloud storage, tracks which file have been processed in checkpoints, infers and evolves schema safely, handles millions of files without performance degradation. It works with S3, which is AWS, ADLS Gen 2, ADLS, which is Azure, GCS, which is Google. Same code everywhere. Now, in production, we have customers processing hundreds of thousands of files per day. Manual file listing does not scale, so autoloader uses cloud's native file notification. It is push-based, not pull-based, so extremely efficient. Now, declarative DAG. This is where Lakeflow really shines. You define table using decorators or SQL DDL. Now, you use decorators, and then Databricks builds the dependency graph, determines execution order, handles retries, provides lineage. Now, the traditional approach is you write the driver program, manage task dependency, handle failures, implement retry logic, build monitoring. So in Lakeflow, you write table definition, Databricks does the rest. Now, that is where we understand high-level flow. Let us see what is the architecture of Lakeflow. Now, the end-to-end architecture, we start with the data flow journey. So data, for example, touches the AWS S3, for example, CSV file, land there. And when new files arrives, it triggers incremental processing. Yeah, this is like autoloader now watches the discovery. The directory always watches the directory, discovers that new files automatically, automatically, and tracks processing state in checkpoints, infer and evolve schema safely, and provide exactly one's guarantees. Now, the bronze is immutable raw facts. Now, raw data plus metadata columns, like you add this extra bit underscore ingest timestamp underscore source file, you add them into the bronze to add like this metadata, and to help you, for example, during troubleshooting or debugging. You would have like a rescue column captures unexpected fields. No transformation here, just ingestion. Streaming table with the checkpoints as well. So the data though is immutable. What happens is like you don't delete or add, it is append only. So you can only append data into the bronze. Yeah, and therefore it is also acts an audit. It just preserve history as well. So everything there is like exactly like the source data. Yeah, as like an image or mirror of the source data, and therefore you can audit your source from this bronze as well. Yeah, so that's the bronze now, and the silver is where you clean your data and validate. You do like typecasting. If it was a string, to change it to numeric or timestamp. You do deduplication, for example, keep latest version per student ID, for example. Yeah, and then you have the expectation drop invalid rows, and then the quarantine pattern for anomalies. Now, uh, Gold is the business intelligence. It aggregates by course code, for example. There's risk scoring, attendance plus the GPA rules, for example. KPI. This is like a student example. So if you would have a KPIs, average attendance, high risk percentage, and then you have expectations fail here because if there is contract violation, because you don't want risk like wrong decision. Yeah. So it is better to fail and rectify that rather than make a wrong decision at the organization level. Now, this is like a comparison. The bronze layer on data quality side is raw and filtered, and you don't need this expectation mode. You don't have any like you don't do drop, or you don't capture quality there. And then the purpose is immutable source of truth. Yeah, immutable means you don't delete, update, whatever. They just append new data set. So it is source of this immutable source of truth. This is the purpose of the bronze. The silver is in terms of data quality is cleaned, typed, validated, and in terms of expectation mode, you do drop invalid rows, and in the purpose is filtered deduplicated fact tables. Yeah, and for gold, this is the decision ready for data quality. If expectation mode is fail on contract break, and it is business KPI and aggregation is needed here. Now let us look at a bit details here, and I'm going to spend like one or two here because this is very fundamental. This is what we this is the reason why we are having this presentation. This is a bronze layer, and it will do the ingestion. And we are saying this, we are using the Spark Declarative Pipeline. Yeah, this is a key part. The Spark Declarative Pipeline. It is using, for example, this pipeline. It imports pipeline from PySpark, from open source as DP. This is a new line, the new line in 2026, which had been introduced by Databricks, and the DLT, which was like a proprietary, is now changing or replaced by the open source PySpark. So you bring the pipeline from the open source in the state of the proprietary DLT. So everything will be changed. Yeah, the logic is the same, but some semantics have been changed here. Now you have the first line here is, you can see the first line is the decorator. The decorator it changes the behavior of a function. This is the function we are dealing with. This is the function here, and we are saying this function is going to be managed table or streaming table, as it were. Yeah, so it will have a certain characteristic. This function here. So it is a managed or streaming table. So whatever happens here, you are going to add it into this table. The name is normally what you do is like you name the function and then the table name the same, but you don't need to do that. I mean, it's not necessary, but it is good practice to have them the same name because they are doing this is the same. This is the table name, the table, and this is like what the table is going to do. Yeah, is defining the table here. Yeah, so we say we are declaring our wish, what we want to happen, and then Databricks is going to take over and do all the necessary heavy lifting. Now we are adding also a metadata here. As again, it's a good practice. We are saying this table is bronze. It is raw CSV ingested incrementally from object storage with autoloader. You can also say the source of the file. The source which come in here is for example AWS or Azure. You can give like as many useful information as possible. Yeah, this is the comment you can add metadata here. Now this is the bulk of work. Again, this is our wish list. We are giving it to what needs to be done to Databricks because I said, don't forget, this is declarative, and therefore you just you say what you need, and then Databricks is going to do the rest. Yeah. Now, the it is a read streaming, as you can see here, and also we are using autoloader. The autoloader is this cloud file. So the cloud file is watching the source path. Yeah. Now you can define the source path, for example, somewhere as a variable. Yeah. And then you can use it here, for example, as a variable. So that's again one of the good practices which you follow. Instead of making mistakes, you can put it somewhere and then you use them here. So anyway, the autoloader here, this one, the cloud file, which is autoloader, just watching this one. If new file arrives, it will fire that there's new automatically something happened, new file arrived, and then it start like streaming the data to the table here. Now, the reason why you need like a streaming table which support streaming is not like a normal insert or loading which we do normally. For example, when you do some loading in a database, you just you do it once, and the table does not expect like data is coming every second or every minute. Yeah. But here, the data is coming every second or every minute, or the change arrives quickly, and therefore the table should support that kind of activity. That's why we are also declaring this way. Yeah. Now, also because there are different file format and they have different characteristic. Also, you need to define the format is CSV file. If it is a CSV file will have like header. Yeah. So we need to say if there is a header, there is the column name is in the header. We need to say it's true. There is a header. The column name is there, and this is again is very important bit. Infer column types. Yeah. Now the data type of a column, it could be if you don't put this one, for example, it will be all the column data type will be string, which means you will have wrong date, wrong data. Meaning, for example, if it is money, if money comes as a string, you cannot add it or subtract from it, whatever it is. So it is very a bit dangerous here. So we need to say infer column types means like if the column is money, it will keep money. If the column, sorry, the string number, it will keep the number. So you say the infer column type to true, and then you have the schema location. This is again a very important. The schema location is you when you do the schema inference. Yeah. So what is the columns within the file? So when you do the schema inference, instead of doing it again and again, you need to put it in a location, and you need to provide the location here, for example. Yeah, it will be very helpful for schema evolution. So if there is any change, also Databricks is going to see in this location whether there was a column before or not. So it is going also to help us in schema evolution tracking, and then in this is the schema location, and this is for schema inference, and then here rescue data column, which is very important. It is underscore rescue data. This captures unexpected field. For example, you say you infer here, and then if something comes in which was not there, therefore it will be recorded here for you. Now you add these two columns again. This is again you add metadata, and then ingest timestamp. You can say current timestamp, or on also source. You can say input file there. Yeah. So that is again the process which you do in bronze. Yeah. So this here is you have, just to recap here. Yeah. What you are doing is incrementally ingest CSV file from object storage using autoloader. That's what you are doing. So only processes new file not seen before, which means maintains checkpoint for exactly one's semantics, and adds audit column for lineage tracking. Now, the key part here is like, for example, the system, this autoloader also keeps like the files which have been processed and with timestamp on them. So If you bring another file, if it says like it's been already processed, it's not going to process them again. That's why it keeps like all the files that have been processed in one place. Yeah. So the file process is kept there. That is why you have this exactly once processing, because it will check the log, the all the files that have been processed, and if already done, it's not going to do it again. And then this extra bit is going to help us uh, the lineage tracking as well. Yeah. Now the other side is like safety, like schema safety. Rescue column captures schema drift without breaking pipeline. Yeah. So new columns in CSV file stored. Yeah. If there is new column, yeah, they are stored in underscore rescue data. Yeah. Malformed rows also captures for investigation. Pipeline continues, no data loss. Yeah. So if you see new files and malformed rows, then the pipeline will not break because it is going to be placed into um, a system here in a column. Yeah, you add them in a column. Now it is incremental by default, which is the autoloader tracks which file have been processed, and because it's checkpoints, store the file, and then only uh, reads new files on each run. Yeah, and therefore it is safe retries after failures. So these are the advantage. Now let us see on the silver layer now. Silver layer, we said we do cleaning and validate. Yeah, that's what we do here. So again, we are using decorator here, okay, decoration here, and the name is silver student clean, and we are using this is silver clean plus typed plus deduplicated student invalid rows reported. So because I was working on the student data, and that's why you see something here. So I'm bringing something which I have done in the previous, yeah. So just as an example, what you put there. So this table for the silver student, if you because I was working on the student, that's why you see the duplicated student, invalid rows, and so on, or the GPA, something like that. Yeah. So, but that's how we put. You need to comment. You need to add extra element into the comment here will be metadata, and then very useful at the later stage to understand what was happening within this silver. Now, the other side is like this is again declarative one. You see the validation also is done using the decorator, and again using the decorator plus, as we said before, the DP declarative pipeline. So we are using these two, the declarative and pipeline, the declarative pipeline. What we are doing here is like we are saying the student ID present. We want student ID, for example. If a student ID is not null and trim student ID is not empty, yeah. So we want like student ID. We don't want it to be null, and we don't want it also to be like empty, yeah. So if that is the case, what it's saying is like drop the row and log it somewhere and continue processing. That's what it means. Expect underscore all or drop it. Drop it means like drop the line and continue. The pipeline will not stop here, like in the old times. Yeah. So the pipeline will continue doing its job. Now the second one is like attendance percentage range. Attendance percentage range number is null or attendance percentage number is greater than 0, and attendance percentage number is less than 100. So if this criteria is done, then okay. If not, again, it's going to drop yeah. And then you have the GPA range. Again, this is student data. You could have different kind depending on your case. This is like an example of GPA number is null or GPA number is greater than 0 or GPA number less than 45. This is the range you want. If it is beyond that one, then you just you need to drop the line. Yeah, and then well-being range is like score number is null or well-being range as the score is greater than 0 and less than 100. Again, if it doesn't fit this range, now drop the line, it says. Now this is like validation. Yeah, the validation is, now the pipeline is not going to be fail, but the row is going to be dropped in silver. Yeah, that's the key part here. You drop it, and then this is what you do. You can, because we have created this streaming table, we can also use read stream, and we can also, I mean, it depends how you do things, but the recommended one is not read stream in silver, but in here I'm just using I'm using stream because what I was doing is like I was just converting it from the SQL. So from in SQL I was doing the stream table, and also I was reading from that stream table. Yeah. So, but here you don't need to do that bit in Python, so you can use .read .table, and that's also I think that's a recommendation as well. Now this is the what you do, the casting, the clean up, and yeah, this is again explicit way of doing work here. Sometimes you might not need all this stuff, but again, I want it to be explicit here to explain what is required. For example, in here, what you are doing here is like in the bronze. Yeah, we are defining now type it here. As you can see, we are starting from this. The bronze here is the table, the bronze student row, which we have created on the bronze layer. Yeah, so we are calling it bronze here. This is the table though, the raw data, student data. Now we are creating another one. We are using is, I call it typed. Now we starting with the bronze. Now we are adding to that bronze table with column updated underscore TS. Yeah, we are saying bring it from timestamp. We are bringing this updated data, update at. Now also we are adding here as well the column course code STD. We are making this to upper, and we are trimming as well. Yeah, we are trimming the column and we are making it to upper. And with attendance percentage underscore number, again we are casting to double. Yeah, and again GPA underscore num, we are also casting to double, and we are also well-being underscore score number, we are casting to double. Yeah, this is one area. Now we have finished with this one. We have adding columns, and we are naming them like what you see here. Now the deduplication, the duplicate. Yeah, so we are saying now the latest. What is the latest one in here? So we are using this one now. This call it a table or view, whatever you call it, with this extra column on them. So what you are doing is the type. Now you group it by student ID. Yeah, and then we are aggregating. We are taking the maximum updates, which we have put it here, and we are saying maximum update time, which this is the latest. Yeah, so we are taking the latest data. Now we are doing the duplication. Yeah, so we are type it is this one, as you can see here. We are just in SQL you put like T or S, whatever it is, as you alias it as T, and then you are joining it with the latest, which is this one. This is grouping. You can see here the grouping here. You are joining it, and then we are aliasing it again with L, the latest, yeah, the latest one. So this is like on t dot student ID is equal to L student ID, yeah? And updated TS on T is equal to L maximum update, yeah? And this is inner join. So, and then we are saying we are dropping L student ID and drop maximum updates as well. So what we are doing here is don't forget, because it is going to find duplicate data and duplicate here max update as well. So it's removing these two duplicates, yeah, and then returns a deduplicated one, yeah. Now you don't need to do this one anymore, yeah. In this declarative world, this is like it's a mix old way of doing things with the new way. You just specify the which one you want. You don't want like duplication on. If you say student ID, then Databricks will take over. But the other one is important. The casting, you need to cast. He cannot do it for you because this is your decision. The grouping, the aliases, this all the stuff you can do, but the duplication is much easier now than this elaborate one here. Now, the drop mode is invalid rows are filtered out, quarantine pattern. So a student must be present. Attendance PCT should be 0 to 100 range. GPA should be between 0 and 4.5. Well-being scores should be between 0 and 100 range. Yeah. So if they are not on this one, so you need to drop the line. Yeah, and quarantine pattern, you need to quarantine it though. Now, typecasting, we said we've seen updated convert string to proper data types. Upper updated at will be timestamp, course code, standardized upper class, and then you have this attendance PCT is going to be double, GP is going to be double now. The deduplication is keep only the latest record per student ID. This is the latest one. So group by student ID, find the maximum updated, and then join back to keep the latest one row and handles incremental updates as well, yeah? Now, why drop at silver? Silver is where you filter anomalies. Silver is your clean zone. You want to remove obviously invalid data, but rather than fail the entire pipeline, drop-in rows can be logged, yeah, for investigation while good data continue downstream. Now, if you go to the gold layer, this is where the aggregation happens here. And I'm going to spend a bit of time later on to show you how you can use the Windows function and so on. But in here, it is a very simple one. I think we are going to use a simple one. Again, this is we are using declarative, and we are saying if course code present is not following this rule, we are going to fail the pipeline. Students non-negative, if a student is not greater than 0, then we are going to fail it. And the high risk capacity range, which is if it's not between this one, also we are going to fail it. Yeah. Now the KPI we are doing here is like we are reading. Now we are not using, as you can see, we are not using stream here. We're using read silver data here. And I think what we are doing here is like first we are doing the silver student clean. We are taking this one. Now we are doing this work here. Yeah, we are building the table here because the table name is going to be where is it? Gold course KPI. It's going to be the KPI. It's going to populate this one. We are starting with silver, and then this is again a table, and it is going to be column. We are going to add column high risk is high risk. Then what you are saying is if when attendance PCT number is less than 50, or when GPA number is less than 2.0, which means it is high risk. Yeah, otherwise it's not. So this is one, and then you are doing aggregation here, scored, which is this one now. We have created one table, and now we are doing another table. We're using all the data in scored, and then we are grouping it using course code underscore SCD, and then we are counting everything, and then we're saying students, the the grouped ones. We are summing this is high risk, yeah, and then high risk student here, average attendance PCC number. We are just we are averaging GPA name as well. So we are also adding to this one to this aggregation with column high risk PCT when the student is equal to 0. Yeah, you put it 0, and then otherwise you say it is high risk student. Yeah, but and then you divide it by the number of students. Yeah, so and then you return the aggregate. This is the final one. KPI calculated the course level aggregation for decision making. This is it's not like that complicated, but you need to spend time to understand what is happening here. But again, it is based on real student data, and it is a mixture of all the new, as you can see here. But if I'm going to do it now, probably I might do it a slightly different way. Yeah? But here we are. So KPI calculation is total student per course. You have high risk student count. We have high risk percentage. You have average attendance and the GPA. And then risk scoring is simple rule based risk identification. It is high risk if attendance is less than 50% or GPA is less than 2. And now you have expectation also. You need to fail. Strong contract enforcement. Stop if broken. Course code must exist. Student count should be greater than 0. High risk PCT should be like between high risk PC percentage in 1 to 1 range. Pipeline fails if contract breaks. Yeah. Why fail at gold? Gold is decision ready, reporting ready. So gold tables feed dashboards, reports, and business decisions. If the data contract breaks, example, negative student counts, invalid percentage, you want to stop the pipeline rather than publish bad outputs that could lead to incorrect business decision. Now, the core concept here is, create a structured streaming source, not batch. Yeah. Now, instead of reading all data once and stop it creates a logical streaming query that runs continuously until stopped processing raw new data only, tracks what it has already processed. Even files are treated like a stream of files. Yeah. So stream of file, we've touched this one before, but I'm just repeating it now. Why streaming for files? Because batch ingestion does not scale operationally. The batch problem is rereads the same files every time, overrides tables, needs custom already processed logic. Reruns are dangerous as well. Streaming advantage is exactly one is processing, automatic checkpoints, safe retry, and incremental by default. Now, the good practices use read stream for ingestion layer, bronze raw ingest, spark.stream, read stream. For silver, though, you need to do the best one would be dp read underscore stream. For gold, you need to see just a dp read batch over curated one. So as I said, I would have done it different these days, but again, it doesn't break. I'm going to update it later on, but this is like there's a bit of old method here. Understanding the format, the cloud files here is Databricks Autoloader, intelligent file ingestion engine, not a file format, it is a source connector. Think of it as a smart file watcher plus ingestion engine for data lakes, yeah? So built on top of Spark structured streaming, optimized for cloud object storage for S3, ADLS, and GCS. Now, what it does internally is there is 7 things you get for free. This is very important to notice here. The cloud files which you use there is like the autoloader, and it gets 7 things for free here. It scans directory for file, yeah? Tracks which file have been processed, process only new files, stores progress in checkpoints, handles schema inference and evolution, recovers safety after failure, scales to millions of files. Now, why Databricks built it? Classic file ingestion is problematic. So spark.read.csv file problems is, so before it was like spark.read.csv file, reads everything every time, again and again, yeah? No state tracking, no retries, no schema evolution tracking, easy to corrupt tables. Autoloader fixes all of them. Now keep this option. Now the option number 1 is cloud file.format. This one is like tell autoloader what file type to expect. Yeah, the format, the autoloader will know the CSV, JSON, or PARQ. Autoloader picks correct parser and applies format-specific optimization. Yeah, that's why you need to give it the file. Depending on the file format, if it's JSON, it will pick the correct parser for JSON, and it will apply the format-specific optimization for JSON. For CSV, the same thing. For PARQ as well, the same thing. Now, this is the format. You have these infer column types, infers column data type from sample files. Without this, all columns default to string, and therefore it will break downstream analytics, yeah? Now, the other one is like cloud file schema location. Now, persistent metadata directory for schema version, mandatory for inference and evolution, ensures reproducibility schema across runs. And then you have this rescue data column, captures unexpected malformed fields in a single column, and therefore pipeline continue even when schema drifts, no data loss or failure, and therefore those ones will be registered here, the unexpected one or the malformed one. It will be on this rescue data column. Load defines directly being watched. Autoloader is watching this one, creates a streaming source that watch this path, never reprocess the same file. Now, the autoloader, which is cloud files, it's reliable incremental file ingestion, and structured streaming, exactly once processing plus checkpoints. Now, DP decorator is this at dp.table and at dp.expect. This governs lineage, expectation, and the observability, and bronze table, immutable raw facts, source of truth. Silver table, clean, typed, validate data, and gold is for business KPIs. Now, the best practices here is do you use cloud file for ingestion? Always use autoloader for file-based ingestion. Never manually list files or loop folders. Now, don't use spark.read for bronze. Batch reads reprocesses everything and have no state tracking, and it also leads to duplicate and failures. So this one is bad. Spark.read, you shouldn't use it for, especially for bronze, yeah? Enable rescue column. Always capture schema drift in bronze. It is evidence that really changed, and therefore don't ignore schema drift. Silently drop in new columns or failing pipeline on drift breaks governance as well. Yeah. Now, set schema location. Always externalize the schema state for reproducibility and deterministic pipeline. Do not delete the schema location. Deleting schema metadata forces rebootstrap and can cause schema inconsistency. Now, do drop invalid rows at silver. Silver is a clean zone, so filter anomalies, log dropped rows, let good data continue. And don't fail at silver for data quality. Failing entire pipeline for single bad rows prevents good data from flowing downstream. Now, the do fail at gold for contract breaks. Gold feeds decision stop pipeline if data contract breaks rather than publish bad output. Do not rely on schema inference beyond bronze. Explicitly cast types in silver. Don't trust inference for critical transformation. And then add audit column, ingest underscore TS, source underscore file, enable lineage tracking and debugging. So don't mix file format in one path. One cloud file source is equal to one format, separate path for different formats. So when to use which read API, ingest file from object storage, reading from upstream streaming table in pipeline, reading from curated table for aggregation, and connecting to databases SQL Server, use Spark.read format JDBC. I think that is not the correct one these days, but it was before. So here we are. So the layer specific guidance is bronze is spark.readstream.format, silver is read stream, and the gold is read. And I think it's also there is a change here with the decoration. Expectation is none. I think we have seen it here. You don't need in bronze, but you need to drop in silver, and you need to fail on gold. Thank you for listening. That is the end of today's session.